Hello and welcome. Good evening, good morning, good afternoon, wherever you are. Thanks for joining the session of our DevNation Tech Talks. So today we have a very special guest. We have Mario with us. Hi, Mario. How's it going?
I also fine, thanks.
Excellent. So Mario is a senior principal software engineer at Red Hat, and AI is pretty much all we're talking about these days, right? So I hear you have a really interesting talk today about symbolic AI, which was something I'd never heard of. I was like, oh, that's interesting. I have to look that up, and so I'm really curious to hear what this session is about. So I'm gonna leave the word to you, and feel free to introduce yourself some more if you want to, and then go into it.
Okay, thank you, Kevin. So yes, my name is Mario Fusco, and I'm the project lead of Drules, which is the rule engine of Red Hat and IBM now. So it's a rule engine. It's part of the artificial intelligence story, as we will see. Probably the oldest part, not the most hyped one this day, but still very useful, I think. And my goal for this presentation is to demonstrate how you can combine a rule engine with an LLM, and how to use Quarkus to have all the glue code to create a compelling app, and also to discuss a bit the theory behind this. Okay. So I don't know if we are sharing my screen now. Are we?
Yes, I think we're not yet. So I'm waiting for our assistant in the background. There we go.
Yeah. Okay.
There we go. Right.
So yes, I already introduced the goal for this presentation. Why I'm going through this? Because these days all the hype is on machine learning, of course. But my point is that machine learning is just a tool, and as any other tool, we need to understand what we can do with it, what is which tasks are a good fit for this tool, but also where it's not appropriate to use that tool, and how we can do better with other solutions, and how to combine this thing, which is the most important one. So in reality, machine learning is just statistics on steroids, as you can as you know, well, sometimes also statistics fail. I mean, even for instance, if you this is what happened to me a few months ago. I tried to buy a washing machine on Amazon. I did it. It was all good, but since then, Amazon is suggesting me to buy even more and more washing machines. So probably they think I'm putting up a laundry, but that's just because there is a strong a statistic correlation between all the washing machine they sell, and they try to upsell to me other washing machine, which under a customer point of view doesn't make any sense, under a business point of view doesn't make any sense. And if you know your business domain, you know that if probably about a washing machine last week, it's the last thing that I will going to buy this week, right? So, and
unless it's like a really crappy washing machine, and and it's like you need to buy a new one every week. No, just kidding.
Yeah, correct. And there is also a lot of confusion about the terminology, I think, meaning that we use artificial intelligence and machine learning, and probably also deep learning, as synonym as interchangeable terms, but in reality, one is a subset of the other. So with artificial intelligence, we define all the software that in a way or another try to mimic the human behavior. Okay, and this could be machine learning, meaning that the machine learn itself how to mimic the human behavior. Or also a rule engine is artificial intelligence. It's not machine learning because you need to give instruction to the rule engine. You need to feed it with precise rules. But it is still artificial intelligence because once you have provided those rules, then it's still trying to mimic the human behavior in that specific context. Okay, and then of course the deep learning is another subset of machine learning, which is the most type technology in this moment, where we use a very deep neural network and LLM that can do crazy things like ChatGPT, like everybody knows. In reality, it's all about fancy naming. If I call my project a rule engine, everybody say, okay, it's 80s technologies, it's all technologies. I can call it a production system, and then it sounds 2000 years technologies. And if I call it symbolic artificial intelligence, it looks cool again. So it's really the same thing, and it's all about naming again.
Nice.
Again?
But now the companies are like, oh, but it's AI. Yeah, please take my money.
That's my point, right? That's the point. And yes, and why you should really combine these two technologies? I mean, why should you combine machine learning and symbolic reasoning? Because of course, in some case, it's very hard, if not impossible, to encode everything with proper business rule. But in reality, you also don't know to go to the opposite direction. You don't want your system to learn everything from scratch in a statistical way, because you know the rule of your own business. You probably don't want the machine to learn them again from scratch and to guess what's going on. So you want to have more control on the business domain part of your application, and you want to encode them in a precise way. I mean, the business knowledge of your domain is really there, and probably it's really the value of your app, the value of your company is there. So you don't want to learn it from scratch. You just want to encode it in a reliable way. And for this reason, there is, of course, a quite big research area when we try to combine these two technologies. At large, this area is called neurosymbolic AI, meaning that, again, we try to combine machine learning with symbolic AI with rule engines. And there are a lots of recognized pattern with fancy naming, as you can see, of how to combine these two technologies. And in my demo, we will see an example of the last one in this list, when we use symbolic reasoning to interact with not with ChatGPT, but with an LLM, in order to provide a chatbot that is also knowledgeable about the business domain. And the reason that pushed me to create this example is this news that I read a few months ago, at the beginning of this year, I think. I don't know if you read this news, but in essence, what happened is that Air Canada had this chatbot, of course, made with an LLM. And this chatbot was used also for customer to ask for help, assistance, and eventually refunds. And this chatbot, while chatting with a customer, totally made up a business rule out of the blue that didn't exist in the Air Canada policy. But in essence, the chatbot told to the customer that he was entitled to obtain a refund of $650 Canadian and for no real reason. It was not you, but it was totally made up by the LLM. And then, of course, Air Canada refused to pay that amount, and the customer went to a low court, and the judge gave him right, and Air Canada was forced to pay that money, because the responsibility of the chatbot is it's an Air Canada software, so it's their responsibility to make it work. Yes, this sort of hallucination in reality, if you have used already any kind of LLM, this sort of hallucination are relatively frequent, and really any reasonable solution for them. I mean, the only solution to mitigate the problem are probably twofold. On one side, you can try to use another LLM to control the behavior of the first, or in the solution that I'm suggesting is we try to use a rule engine to instead implement the actual business rule of the application, as I suggested before. Okay, so you really don't want to have hallucination when we are speaking about money, when we are speaking about a refund policy, or when a bank needs to decide if they can give you a mortgage or not, for instance, right? You really want to apply very precise business rules in those cases, and it has been, as I said already, also mathematically proved that it's impossible to totally get rid of this hallucination. So, as I said, one of the solutions is that, okay, let's use an LLM, a second LLM, to validate the behavior of the first one, which is, yes, something that is in use. It's a possible solution, but this sounds to me as a 20 years old joke about XML. At time they said that XML is like violence. If it doesn't work, you are not using enough of it. And now we are probably saying the same about the LLM, right?
So, right. Yeah. Yes. Yeah. And then somebody could say, like, well, now we need to have yet another LLM that validates the second LLM that validates the first one, because how do we know that?
Right, something like this. So and there are actually solutions like this. I mean, there are you can put together an odd number of LLM voting for a given but it becomes really complex and hard to take under control. So there are proposed solutions like this. As I said, my proposal is a little bit different. I'm trying to combine an LLM with a rule engine. So what I will do in my demo is that I use an LLM to chat with the customer and collect the data from the customer. But once I have that data, I want to put together this data, send them to Druce, and actually ask Druce to calculate if there is a refund is owed, and what's the amount. And as you can see in this demo, I will use Druce for a twofold reason. One is for this refund calculation, but the second reason why I'm using Druce here is also to internally implement a state machine. Okay, and this is also typical during an iteration with a chatbot. You go through different stages. In this very simple example, the first stage is that you are collecting data from the customer. So the first stage is extract the customer data from the chat, and then when all the customer data have been collected, you can move to the second state where you collect the data from the flight and the disruption that or the delay that the customer suffered. and then when you have also collected all the data about the flight, then you can move to the third state and finally calculate the refund. Okay, so I will try to demonstrate how this works. So let's okay, this is this demo is on this project on my GitHub repo in case you want to give it a try. So let's give it a try. So I will start the Quarkus server here, and while I will demonstrate how this thing works, I will also guide you through a bit into the code to check how this stuff is implemented. Okay, so I have this demo. Okay, I'm accumulating a few examples in this demo. We will give a try to this airline refund one. So let's try to start chatting with this bot. Okay, so I will simply say hi, and here you can start noticing two things. The first one is, of course, my great skills as a front-end developer, as you can notice. And the second one is that, yes, this interaction will be quite slow now. This is because I decided to run the LLM locally. So in this moment, I'm streaming the video and running the server, running the LLM server. So everything is running on my machine. So this is, and of course, the LLM stuff is the more heavy, and so it takes a while to reply. But let's see what's happening here. So I created this application with Quarkus, and to put together rules with the LLM, I'm using these two extensions. One is the Quarkus extension for rules, and the other is the Quarkus extension for LangChain4j, which is the tool that I'm using to talk to the LLM that is running locally. And with Quarkus, as usual, you can configure everything in a declarative way with this properties file. So I'm configuring here which model I want to use with my Ollama server. What's the temperature? I had to use a quite long timeout for the reason that I explained it before. And then, yes, I'm also logging the requested response just to have a better understanding of what's going on. And this is the configuration of LangChain4j, and then I have the configuration for rules, where I'm configuring the knowledge base and knowledge session for this different application. Okay.
Okay, and just for the
yes.
for the audience, I did paste a link to the GitHub, so you can follow along with the code there too.
Okay.
Because sometimes your screen gets a little bit blurry, but that way for sure they can see the code too in case.
Okay.
Right.
Okay. So if there is something not very clear, please feel free to interrupt me. So okay, this the LLM finally sent me a first reply. He's telling me that if you remember, I described this application also in terms of states. So we are now in the first state of that state machine. We are the role of the chatbot now is collecting the customer data. Okay, so this is what it's doing now. It is basically asking for my name and my age. That's all. Okay, so let me try to put in my only my name. And let's see what happens. So just to give a better look at this application in the meanwhile, what I'm doing is that I'm sending post to this REST endpoint. And at each iteration, it happens, basically two things happens. First of all, it tries, it reads the current state from the state machine, and now we will see how it is implemented. And it tries to extract the data that are relevant for that state. So extract data will mean extract the customer data when I'm in the customer discovery state, and it will mean extract the flight data when I will be in the flight discovery state. So how this thing is implemented is that I have this session data object that basically contains a session ID and the data that the system have been able to extract from the customer and the flight. So what happens here is that it is calculating the state with the state machine, and the state machine is implemented, as I said, with rules. So what happens is that the data are passed to rules, and if I still don't have, this is very simple to read. If I still don't have a customer that I'm in the state where I'm extracting the customer. Otherwise, if I have a customer but not a flight, then I need to extract a flight. And when I finally have both, I'm in the third state when I can finally calculate the refund. Okay, so I'm still in this first state where I'm extracting the customer data. And the fact is that I provided my name, but I didn't provide. Okay, of course, something went wrong already.
It's the live demo effect.
Yes, the live demo effect. Let me check what's going on. Okay, so at this point, okay, yes, no, sorry, it's working. So what happened is that it asked me my name and my age. I only provided my name, so the system is still missing the age, meaning that the customer extraction data stage is not completed yet. It's still in that state. Okay, so it's now asking for my age. So it has the name, it's missing the age. So I will put my age in. Let's say I'm 70 years old. And now it should put everything together and be able to extract the customer data, meaning that at this point, I should have this customer record should have all the data with the first name, the last name, and the age. Okay.
So is the customer, you might have already said this, but is the customer data in a database, or did you load some data with RAG, or how are you doing?
No, well, I didn't. Okay, let me show how the data extraction is performed. So as I said, I retrieve the current state. Then from the state, I can say extract data. And as I said, I'm in the state extract customer. So to extract the customer, it calls this service. This service is configured with Quarkus and LangChain4j in a very declarative way. So I just need to create an interface with some notation, and the implementation of this interface is created for you by the Quarkus extension. And what I'm saying here is that extract the information about the customer from the text, where text is the is the chat, is the data that I'm giving to the chatbot. And I'm also saying, okay, extract this data in a JSON format. Okay, so what happens is that the chatbot will give me the data in the JSON format, and I just, and at that point I just deserialize the JSON and create the customer record. This is still working. Yeah, of course I have also have the video, so it's running a little slower than usual. But anyway, this is for the customer. What happens next is that, of course, when I will move to the next state, instead of extracting the customer data, we'll do exactly the same thing for the flight. Okay. And then I also have two chat service that are configured in these two states. One is to ask for the user about his data, meaning the name and the age, and the other is for the flight data, meaning the number of the flight and the kind of the disruption. Okay, so now all the customer data are here. Let's see if okay. So basically, this is the JSON that the LLM is replying to me, and what I'm simply doing is just taking this JSON and deserialize it into the customer record, and this is how I have a customer. Okay, and that's all. So now I'm in this second state because the customer is now valid and no longer null, but still I'm missing the flight. What I can do now is saying, for instance, I was on flight 22 and it had a delay of 4 hours. Okay, something like this. So let's give a look. So now it will happen basically exactly the same thing, but now I'm in the second state. So I'm collecting the data of the flight. For the flight, I'm requiring the number of the flight and the delay minutes. Okay, so what I expected that it happens now is that at this point the application should have okay, now it also has the JSON for the flight, so also the flight as a value. What I expect now is that now the session data is complete, meaning that I have both the customer and the flight, and then I can take this session data and send it to Druce to a different session that now will calculate the refund that I should have. Okay, so it recognized that the delay in minutes, I said 4 hours, it recognized that the delay in minutes is 240. So what I expect is that my refund should be 240 times 2, so it should be 480. And since I say that I'm 70, also this second rule should be applied, meaning that the refund should be increased over further 10%. Okay, so it should give me $528. Okay, so what I'm saying here is that I'm using the LLM for a friendly chat to collect the data in a very friendly and user-friendly way. But then when I have collected all the data, I want to calculate them in a really precise way These are not rules that are made up by the chatbot. These are really my business rule, my refound policy, and I'm applying them precisely. Okay, so this is the goal of the application.
Yeah.
Is there
Yeah,
any
I think that
question?
makes a lot of sense in terms of you can leverage AI for the large language model and the features of having a more human response, but then still not rely on it to make up any kind of rules. You're in control of data, so
Correct.
that's really cool. Yeah. Yeah, I don't know if
Correct.
we have any questions in the chat yet. It doesn't look like. So if anybody has any questions, definitely chime in and we can take them in real time. If not, Mario, you're free to continue because I don't see any questions yet, but
Yeah.
maybe they'll come.
Okay. Okay. This is was my plan B. Of course, I took a screenshot of a former execution just to demonstrate how it should be. But for luckily, it works. It worked as expected this time. And in reality, many more example of this possible interaction between an LLM and a rule engine. And I asked ChatGPT to give me some example of this, and it generated a quite extensive list of example where actually it makes sense to combine these two technology. The first one is the customer support chatbot, which is the things that I just demonstrated, but there are lots of other possible application. And we are doing some other research, of course, in the area of combining the use of a rule engine with the machine learning tool. And in reality, I believe that that there could be these two different point of view. The traditional rule engine is fed with data and rules, and then it applies the rules on the data and generates some answers. And if you think about it, you instead feed the machine learning with data and the answers, meaning that when you train the machine learning, you give the expected answers, and it tries to extract the rules from the example, from the answer, right? And if you think
Yeah.
about it, we can combine these two things. For instance, feeding the machine learning with the expected answer and the data, and then the machine learning can generate the rules, and at that point you can let's say create the business rule from the expected answer and the data, instead of providing them explicitly, and then you have those business rule and try to adjust them if necessary, or apply them as they are. And we also tried this approach, and I think that with this approach we can combine the pros of both technologies. So in reality, the machine learning technologies is it's much more flexible and can handle complexity for vast amount of data, and generate rule in an automatic way without having the user to encode them. Okay, but it can suffer from data dependency. For instance, when you overtrain the machine learning algorithm on a specific data set, so it will only work for that data set, and that's all. And the other problem is the fact that the biggest part of neural network and machine learning application are black box. You don't know why a decision is taken. Okay, so it may apply some set of implicit rules, and decide that the bank can decide because of them that they cannot give you a mortgage. Okay, but at that point, the bank cannot tell you, look, I cannot give you a mortgage just because the machine say no. I believe it's unfair, but probably also illegal. They should give you a human readable explanation. So you really want to generate the business rule out of what the machine learning learn on its own, to give an interpretable explanation for the decision taken. Okay, and this is very meaningful and required, for instance, again in the financial field, but think, for instance, also about the medical field. Okay, if it give you a diagnosis for something, probably you may want to know why, right? So there are a lot of fields when taking black box decision is simply unacceptable. That's the thing, and this is why you may want to integrate the machine learning algorithm with a rule engine. So what we did is instead of providing business rules, as in my former example, we try to let the machine learning to generate the rules, and there are a few algorithm to do this thing. The one that we try is called the 1R algorithm, and 1R stands for one rule, meaning that it generates a rule at time from the data, selecting the subset of data that gives the highest accuracy and the highest coverage from the expected output, and then it continues this process iteratively. So, okay, this is an example, an existing data set. So what happens is that you select the rules with the highest score, and then you create one rule, and then you create another, and so on. Okay, so you have this very iterative process. I don't want to give into the details of the algorithm, but there's another project where you can read about it. I have the link at the end. We, for instance, give a try to this solution for the diagnosis of diabetes cases in the early stages. So we had a list of features. We selected the 4 features that are most related with the prediction, and we let the 1R algorithm to generate the DRL, the rules from what the machine learning learned, and then you iteratively add more rules or rules that amend the other to improve the coverage and lower the errors. So yeah, this is still very experimental, but I wanted to mention this. And if you want to check this second project, is this one made by my colleague Nicole, and is this Truth ML project. So you have the link to both the examples that I presented. And yeah, just to drag a few conclusions out of this thing, the general goal of artificial intelligence is mimicking the human behavior, and there are many different ways to do this, and there are many different reasons why you may want to do this, and there are technologies that fit good or bad this task in different situations, right? And I believe that machine learning is not a replacement for symbolic reason. They are two very complementary technology. They are both very useful and meaningful, and actually there are many applications when you may want to combine the two and generate and leverage both the flexibility of the LLM, of the machine learning algorithm, and the adherence to the business rule that you can encode with a rule engine. And yes, this is all I have.
Yeah, no, it's great because I think I feel like, with the big explosion of generative AI, everybody wants to use AI, and they're trying to find use cases, and everybody creates their chatbots, and just like the Air Canada, but there's many other examples, right? And it totally makes sense, like these kinds of use cases where we actually leverage what is nice and cool about AI, what we can actually take and then combine it with our existing technologies, our existing ways of working, which are tried and true, and then integrate them into what can actually be like a next generation application. And I think this is a good example of how to do that. And like that graph, right? You have like the hype graph where oh, there's this new thing, and you have the big hype, and then you have the trough of disillusionment, and then eventually we find like a stable way of integrating this. And I think this
I
kind of
believe
leads in
that we
that
are
direction.
still on the peak of the hype, meaning that
Exactly.
also we haven't well understood how to really use in an effective way this technology. We are experiments, as I said, we are experiments with a lot of different patterns. We are in a experimental stage, so we are trying different solutions. Some will be good, some will be bad, but we will see. And at the end of the day, it is just a tool. There is nothing magic. Even if it seems sometimes it seems magic, it's just another tool that you want to add to your toolbox, and you want to integrate with the rest of your application. And Quarkus allows you to use this LangChain for Gen extension and do this in a very easy way, really straightforward, very declarative. As I demonstrated, you just say how you want your chatbot to behave, and give it some instruction, and it mostly simply works. Yes, not always, but it's still a bit unpredictable from time to time, but it simply works.
Yeah. So how do you go about testing the results, right? So because we kind of joked about like using an LLM to test your LLM. So in this case, you do have your rules, so you should have a more like defined outcome, deterministic, let's say. So but the results might still be in a free text format, right? So do you then extract that into, do you ask maybe the LLM to give it to you in a JSON format or something that you can test, or how do you go about that?
Yeah, as I said, when I want to extract the data from the JSON, yeah, it's always enough to say this, and the LLM almost always behave in a reasonable way. Sometimes, it replies with the JSON and gives you some explanation or put some comment inside the JSON. So, sometimes it hallucinates because it is trying to help you, but it's in reality is hallucinating because it's not what I asked. And then if I try to parse that pseudo JSON, it will break my application, of course. So yes, it's not really predictable, as I said. I mean, the one thing that you can do, for instance, is playing with this parameter that is called temperature. The default is probably something around 1, meaning that one is the default is if you go below 1 or as close as possible to 0, you are telling to the LLM, please don't hallucinate. In reality, what you are saying is that, as I said, that this is a statistical tool, so it concatenates words in a statistical way. If you give the lowest possible temperature, it always concatenates the words with the highest probability to be true, to be the right thing. If you give higher temperature, it try to use the third or the fourth more statistically probably thing, meaning that in this way it can be funnier and useful if you want to have some sort of iteration with more, let's say,
some more creativity.
with more creativity. Yes, in a more open, sometimes you really want to constrain. For instance, I have a second example here that is a generator of passwords. And then, so what I'm doing is that I give the LLM a topic, and then I ask it to create a password for the topic, and then I have some rules to manipulate the password to be compliant with some other rules. The usual rules for the password. You need a lowercase character, an uppercase one, a symbol, the blood of a virgin, and stuff like this, right? So in this case, I wanted my model to be more creative when generating a password. So for that model, I'm telling, okay, use a temperature of 10 instead of 0.1, as I said here. So what I'm doing here is that I have what I call the not model, a model with a higher temperature, and I'm using that hot model to have a password generation with more creativity. So you have a few way to tune your application to have a bit more control of what's going on, but still you need to encode your application with expecting that something can go eventually wrong and have some plan B, meaning catching the fact, catch an exception when the JSON cannot be parsed and retry again, or try to extract the JSON string from the rest of the things that it replies to you. It's really many times it's a trial and error process. Yes.
Right. So we have a question from Brendan, who asked if there's a way to leverage InstructLab with these hybrid approaches. Right. So InstructLab allows you to basically train or fine tune a model with an easier way than to go all the way into the data science, right? You can create these YAMLs and then train your models. So is there a way you think you could leverage InstructLab to maybe create some rules that way? I'm just thinking of.
Yes, I'm playing with InstructLab as well. Let me check if I can find it quickly. 1 second, because I have this other. I don't know if you see my screen, but
Yes,
I have. Yes, now you do. I'm playing with InstructLab as well. I have this other starting to put together this presentation about this. Here I'm trying to teach Instruct Lab how to generate the TRL. Okay, how to generate the rules in the Druze language. So I started with a very out of the box Merlinite model that doesn't know anything about rules, and indeed the things that it generates is totally nonsense. And then I tried to train this model. Well, I don't want to go through the whole presentation, of course, but then I tried to train this model, and at some point it started generated rules in a very meaningful way. So my prompt here to Instruct Lab is generate a rule that does something, and it worked. With some caveat. I mean, it's not 100%. Well, this is a bad example, actually. Okay, this is a most reasonable one. You see, it gives me the rule, but then it also gives me a very long explanation. So probably you may want to filter just the code of the rule. So it is sort of working. This is also experimental. But yes, you can train Instruct Lab and try to use it. And again, you in the idea that I was showing before, the one of combining LLM and the rules and trying to create rules from the data, this could be another interesting solution. Still
Nice.
really experimental, I understand, but in essence, yes.
Yeah. Well, that's how it all gets started, right? We experiment and then we figure out
Yes.
what makes sense and what doesn't. And probably some of the use cases that we're trying out in this whole AI bubble might not, make it in the end, but I think some others will. So curious to see how that goes. Anyway, I don't see any other questions, so I think we can wrap it up. Thank you very much for this session. It was really enlightening to me. I really enjoyed it. I hope our audience did too. And I'll see you at Devox in October, I think, in person.
Yes.
And we do have a last minute question here. So Brendan again says, so one could possibly take a set of diagnoses and possibly create a set of DRLs. Very cool if it could work.
Yeah, very cool if it could work. I mean, your mileage may vary. I mean, it may or may not work. I mean, it's still really in an experimental stage, as I said, but that's the final goal. Yes.
Yeah. All right. So with that, thanks everyone for tuning in or for watching this in delay. And then you can still reach out to Mario if you have questions.
Sure.
And yeah,